My name is Deborah Barron, and I'll be introducing today AIG and their story. We're in the final stretch of the day, getting to happy hour, so I really appreciate all of you being here today. What you're about to see from AIG, what they've designed, I think is going to make this one of the best sessions of the day, so text your friends, tell them to come. And the reason why I think it's remarkable and memorable is because what they have done is similar to what Zillow has done for the real estate industry, right? They've taken us from looking at the Sunday paper and paging through real estate sections and talking to people, right, to Zillow, right, where you can get all the information in one place, look at it from different ways, see how it's related, get images, get text, get numbers. It makes it easy for the end user. It's a complicated array of data, but any consumer can pick that up and do. In fact, tell me in this room, who has used Zillow before? Yeah. Would you ever go back to using the Sunday paper? Yeah, nobody, right? Why would you, right? Because with Zillow, not only do you have all that information in one place, but you also have the ability to look upstream at historical data. You can see property values. You can see upgrades and changes to the property and how that has impacted property value. You can see comps, related properties, right? If you're a seller. If you're a buyer, you can measure the impact of changes you're going to make to your property, potentially. You can measure the downstream impact of those changes on the value of your property, right? So this is an apt analogy for what Jim is going to talk about today, Jim Barrett from AIG, and the smart people in the innovations team there. It's an apt analogy because it's a phenomenal, it's a huge leap forward from the Sunday paper to Zillow, right? It's a leap in efficiency. It's a leap in visibility that speeds transactions because of better insights. All the data is there, right? But now we have the insights, we have the accessibility, we have the visibility. So let's bring that back to organizations, right? Organizations today are struggling to make that leap, right, from paper to plastic, right? But they're burdened under the weight of huge amounts of information, rows and columns of data, text documents that have been digitized, but basically this mass that is just impenetrable by mere humans. On top of that, there are static diagrams. So there are visualizations, but they're not interactive, and the moment you print them, they're obsolete. And then finally, all of this information is sunk into a complex network of legacy systems. Legacy systems with information that flows from one to the next, so that a small impact upstream could have a huge impact downstream. And that impact could have upside potential. It can also have upside risk, the issues you cannot see. You cannot see the impact. You cannot see those interconnected components. We lack that visibility. And so when I was thinking about the keynote this morning, and Emil was talking with us about some graph stories, right? The medical insurance company and Adobe's Community, those were problems that could be advanced and solved by visualizing the network, right? These are graph stories. And so when I heard about what AIG is doing with the integrated operating environment, isn't that a sexy name? What they're doing with the IOE, integrated object environment, excuse me, what they're doing with the IOG to me was one of the best graph stories I think I've ever heard. So it was really an honor, Tom Sawyer Software, to be brought in by the innovations group, by Jim, to work with the design and build the application. And let's see, there's so many things, so many buttons to push up here. I have to make sure I push the right one. And many of you in the graph community have probably already heard of Tom Sawyer Software. So I won't spend but a couple of minutes. Some of you might have even met Brendan Madden, our founder. He's been in the graph space for over 20 years. When he got out of grad school, worked in large network graphs at TJ Watson and then started Tom Sawyer Software. Many of his peers out of academia have gone on to become PhDs. But in our world, we brought in a lot of math and computer science majors, engineers, and PhDs that are floating around the world, helping us continue to build better graph technology and work with customers like AIG, because they think of things that we've never thought of, and we collaborate, and it's just a lot of fun. So it's really my pleasure to be here today to talk about it. The kinds of things that we do are very similar to many of the use cases that Emil talked about this morning in financial services, things from anti-fraud to catching the bad guys by peeling back the many layers to see who's behind all of it, the solutions in networks and operating environments and infrastructure, some interesting new areas in terms of architectures and models. And so at the base is a platform to build applications like the one you're going to see here in a moment. In addition, there are some exciting new areas that we're applying graph technology in use cases that weren't mentioned this morning. Things like model-based systems engineering, where customers like Airbus are mapping an entire Airbus 320 so that architects can do design work and maintenance engineers can do upgrades so that you could zoom into one system and then a subsystem and then to the individual components, because a supplier in China has just changed a component, they're sunsetting it, and you're wondering where this component exists across the aircraft and where along that assembly line it's actually placed so that you can do change management. So these are the kinds of program management activities that are going on that I think ultimately are going to take graph to that next level. So just to kind of pull back, give you that big picture, it all starts with the data and the attributes, and Jim will talk more about how that plays into his modeling and the demonstration he's going to show you. All of that wraps up into a nice data model. That information is then processed, filters, algorithms, analytics, to produce different views. And this is where graph is really, really different and valuable. So it's that same corpus of data, right? But different business units have different needs. They're asking different questions. They're solving different problems. And so we're getting a lot more value out of that same core set of data. It's an exciting time, I think, to be in the graph world. So with that, I'd like to turn it over to Jim Barrett, AIG.
Great. Thanks, Deborah. There's a few times in your career when you fortunately get to work with superstars. And building the Integrated Object Environment, IOE, POC, was one such time. Gordon Cooper planted the seed. Sean Keenan developed it, nurtured it, grew it. And in fact, if you read Sean's book, Financial Innovation, Financial Institutional Advantage, you'll see a lot of the core principles of the IOE there. Gene Goffman, who designed the data model for AIG that runs on Neo4j, brilliant data model, very flexible. Ian DeBreo, who loaded Neo4j with our information. Jason Massimo, who put the topology together from dozens and dozens of diagrams done over the years. I also want to thank AIG's model risk management team, countless names. I can't even begin to, you mention one name and then you slight somebody who you didn't mention. The ERM leadership team, all the way up to the chief risk officer, and the AIG IT team, along with all of Neo4j's experts. Thank you, Daryl, and all of his colleagues. And a special thanks to Chris Tanner of Tom Sawyer Software. Excellent. So this is amazing that I'm actually standing up here, not far from where Superman and the Amazing Hulk are, but I'm talking about something that's been near and dear to me since I was a boy. And this is an airline timetable route map that I collected when I was about yay high. And I was fascinated with the visualization of the potential. Now, obviously at age 9, I didn't understand that. But now, after studying the power of visualization over text and tables, I can appreciate what I appreciated at 9, which was This, in a single page, is the potentiality, in this case, of mobility. And so that's been my theme through my career. Starting when I got out of college in 1980, I began in earnest to do diagrams in a way to help myself understand material, in a way to help the people that I was working for as a business analyst understand their work role. So at AIG, we've had a few problems to solve. Now, when we realized the potential of what we were doing, we went full tilt, all the way to step 3. Let's make full use of this. Let's make use of the attributes as we connect them to the objects and the topology. Let's do some really sexy stuff. And we did, and we did. But lately, the business leaders of AIG have approached us and said, well, you know, our big problem is we've been asked to draw process maps for the whole company, each unit at a time. And we want to associate those process maps with particular applications that hold data that tell us about those processes. And that's exactly what step 1 is, a repository for topology. That's what the IOE does first and best. Secondly, where's the risk and where does it go? So I think of risk as failure at a point, which would be mostly your IT failures, failure of an application, database, and failure through risk propagation. And I'll talk both of those to both of those in the demo. And then measuring path and tree risk, that's perhaps the most complicated thing. We'll talk a little bit about that in the demo. So we originally started on a relational database years ago, storing our diagrams, our infrastructure diagrams. And we went to the vendor and we said, well, we need to do some pretty complex queries now. Complex queries. We need to go 20 hops back on 100 nodes, and we need to know some particulars about the topology. They came back and they said, well, 9 hops is about the most we can do in a reasonable amount of time. After 10 hops, we kind of fall over. So that made us realize either we need a new technique or we need a new technology. That led us to Neo4j. Best in class, and they're adding powerful features. Kettle to be, I can't say enough about that. We're excited about that. Cypher is the language. I just heard last night at dinner that the core parts of Cypher will be likely adopted by the ISO to be the GQL, which will be the standard graph database query language. And then the support. I want to thank Daryl and all of his colleagues for support across AIG and as well as a great deal of patience. So after Neo4j was found, I went to the Neo4j website and I looked at, well, who are the visualization partners? And I looked, all fine companies, but one stuck out in particular, and that was Tom Sawyer Software, because their core competency is exactly what we needed. The data flow diagrams we were looking at, they had been working on for a long time. So I called up Brendan and I said, Brendan, this is what we're doing here. We're interested, but our number one focus is your visualization intuitive? Is it fun? Is it easy? Is it Apple-like quality? Because that's what we need. Because in something like the IOE, as you may have already started to think about, the danger is it gets stale. The information gets stale. And as Deborah said, you do a Visio diagram and within moments it's out of date. Well, that's a problem no matter where you are. But a particular problem when you're advertising to the world that, hey, I've got the latest and greatest on your topology. So my number one way to mitigate that risk is let's get something people want to use, not have to use, but want to use. Brendan said, hey, we've been working along those same lines for 2 decades. So that cemented that relationship. I might also want to add the enthusiasm and professionalism of the Tom Sawyer Software folks. I'm overjoyed to be working with them. So this is it. These are the 4 components of the integrated object environment. It's a patent-pending concept by AIG using 2 technology components, a graph database and a visualization layer. So you have Tom Sawyer perspectives in the visualization, you have Neo4j, and then the 2 content components. You have diagrams and you have attributes. I'll talk a little bit about diagrams in the next slide. The attributes, and this is a little bit of terminology. So I know that Neo4j uses the word properties. all fine and good. We use attributes. Some people use reference data, or the technical term structural metadata, characteristics. It's all the same. So think of it as properties or attributes. That's a key ingredient here, because as you'll see in the demo, those attributes are used to run queries, to go to different dimensions, to actually even be used in algorithms and eventually optimization. So about diagramming, and because visualization of processes, procedures, and infrastructures is near and dear to my heart, it's my favorite topic. And I'll say that in my tenure, in whatever field I was in, with the airline industry, or whether I was in financial services, in the brokerage business, or insurance, the people that I talk to, there's no one person who really knows the end-to-end diagram structure. So you get a bunch of people in the room, and you say, well, how does this work? And it bubbles up the truth. It's like a dialectic. Everybody's trying to figure out, well, how do I send this information? And eventually, if you're really disciplined about getting this into a diagram, you're going to get to the source of the truth. And maybe that means you have to go to subject matter experts outside the room. The second key ingredient, besides this being a dialectic, is the standards. So we developed standards a couple years ago, company-wide, for analytical infrastructure as seen by the business side. This is not necessarily what the IT teams need, but this is from the business side. What are the shapes we use? The standard shapes, the best practices, it's left to right, top to bottom. And with that, we then take what we learn from the subject matter experts, put it into a Visio diagram that's standardized, knit those together, and load it into the IOE. So, two key ways to differentiate a depiction of data flow. And this is sort of keeping to industry terminology, but we deviate a little bit here. First of all, we simplify it, because it's incredibly complex out there, BPMN and all this other stuff. When we think about it, network view, you can think about it as that's failure at a single point. And you'll actually see that in the demo. We prefer the linear view, because I like to think of financial services companies like insurance companies as consisting of factory floors of tools, databases, information processing tools, delivery tools, models, delivering a calculation to the business to drive profitability, to sell premiums, compliance, et cetera. So now we're going to get to the demo and the demonstration of the product. This was done. This was a video done of an actual IOE proof of concept Tom Sawyer Perspectives application. And I want to walk through, again, in order of complexity, talk about the fact that it's a process map repository, perhaps most important. We're going to show you how we can take attributes and map them to a different dimension. And then we're going to finally talk about taking attributes and putting them into an algorithm. So here we are. We're in the perspectives. What you're looking at is 2,000 object infrastructure, data, databases, models, information process tools, data delivery tools. And imagine trying to do what I'm going to show you to do in Visio diagrams on a SharePoint. So we're going to select an object, object 504, and it's popping up there. And now we're going to say, let's isolate. We want to isolate the upstream flows into this object, and we want to isolate the downstream flows. We're going to do that. And by the way, our data flows are captured as nodes in our Neo4j, not that it makes a whole lot of difference. You see they're color-coded. Those colors actually are informed by attributes stored in Neo4j. We're now going to isolate this topology from the overall topology. And now you have the opportunity to query just this selected opportunity, this selected topology on its own. You'll notice that this is pretty much an end-to-end picture. The databases you see there, or the source databases, bring data into AIG. And downstream, you have the data delivery tools delivering it to the final user. So now we're going to switch the attributes that we're color coding on. We're switching now to a risk attribute that's found in a number of different authoritative inventories. Again, these authoritative inventories are managed and governed already. This is not the province of the IOE. The IOE takes advantage of the attributes that already exist in the company and leverages them. As you can see here, here's a heat map of the ranked order, model risk scores, and application risk scores and database risk scores. So again, you can have a multitude of attributes. We have, in the case of the proof of concept, we loaded about, I guess about 50, but we had the option of loading over 300 attributes. So now we're going to focus on 6 different tools that are in the far upstream side of this topology. Now you'll notice that the 528 is a high-risk tool being supported by 4 low-risk tools. So the first question you say, well, wait a minute, is all the good work and good effort put into those 4 tools negated in 528? I mean, it's a high-risk tool. That means things coming out of 528 are questionable. So that's the first question that I ask. And again, this is something that an authoritative inventory silo table database might not be able to show you because you wouldn't be able to see the topological connection. By the same token, what about the database? Is that database feeding, is it risky because it's feeding poor data quality? Okay, so we've got a couple questions here. And I like the phrase actionable insights because it fits so well to what the basic premise, the basic capability of the IOE is. So we've switched attributes now. And then the next attribute we're going to look at in the heat map is a criticality attribute. And this shows the criticality of those 4 in the center. It's fairly critical. Those need to be brought back online within 24 hours after failure. But the 2 on the end, best efforts. Okay, so now we have another question. To those who are the users, the ultimate users of this, how critical is this? If it's really critical, then maybe those green guys should be yellow or maybe even red. If it's not so critical, do we deploy our resources elsewhere? And again, these are topological actionable insights that you can't see easily. And not only that, but as these attributes change in the authoritative inventories, those will change in the IOE. So try doing that in Visio. It would be an endless repetition of Visio diagrams, etc. So now it's escaping the topology. Pull him back. There we go. So now what we want to focus on is the fact that this, let's suppose I own that database and I'm making a change. And the change is a simple format change. I want everybody downstream to know the change I'm making. So I can select the object and right-click, and I say, send notification to everybody downstream. And we know everybody downstream because we're getting that information from the authoritative inventories. And send it all downstream and say, hey, we're making a change to the format. If anybody's got a problem, let's push back. By the same token, I can also go to the end user and say to the end user, all right, now you have the capability is if a new user, let's say I own a delivery tool and a new user comes to me and says, you know, I'd like to use your data for report X. So I would say, well, let's see if the model owners who are contributing to that data really believe their model is fit for purpose. So an alert would go out from me as the data delivery tool owner, and I'd say, is this use in report X fit for purpose for your model? So again, it creates a community. And this is something that I've seen for years, for decades, as I work with groups as either a business analyst or a project manager, in having them understand, okay, this is my world, but what my world does is feed another world. I don't really know who those people are, and I don't know exactly what they do with this information. This allows you the end-to-end, not only awareness, but the accountability, so that, hey, if the data quality I'm getting from my community there in yellow is not so great, maybe I should look a little further upstream. Maybe the problem is with the data coming into the company. And along with community, I guess I reach a sort of an altruistic view of the use here is that, yeah, we talk about propagation of risk, but how about propagation of contribution? How about, you've been sitting in this job for 4 years and saying, what exactly am I doing for the company? This is a way to see where the contribution of the teams and the individuals in the company are going. Once you hook the business metrics up to the downstream side and see, okay, I've got a factory floor, I've got 500 people on different teams working for this, and we produce X amount of premium revenue for the company. That would be your propagation of contribution. Okay, so now we're going to go to our network view. And as I promised, this is another way to look at topology. And I like to think of this is where you can easily see your failure to point risk. Obviously, in this topology, and by the way, this topology is for a single use. So there could be 20, 30 uses that are shared among these hundreds of tools. So the question here is, all right, of the nodes that are receive highly concentrated paths, what's the risk of those nodes? Who owns them? Is there knowledge sharing going on? There's another question for you. Every company loses knowledge share, but is that knowledge documented? Which gets back to the whole idea of diagrams and getting a dialectic of the truth. Now we're going to go to using attributes as a method to go into different dimensions. So we're leaving the topology of infrastructure. We're now going to the physical geography. These happens to be fictitious locations of AIG's server farms. For obvious reasons, we can't reveal the real locations. But this is where your tech risk people would say, well, okay, this is great. Now I know where my servers are that connect to my topology. Should I have failure in the servers, what part of my topology goes down? Who's affected? So this gives you a vertical integration on a different dimension. Not only that, but this is just one of many dimensions you could use within a single company. So think about org charts. That's a dimension. That's a topology. Think about the way cash flow runs in the company. That's a topology. Those attributes or those nodes, if linked to your analytical infrastructure, then you could go back and forth between different topologies. Okay, so now we're going to go back to the original view. And now we're going to look at our third and final use, and this is the one this is our third step. This is where we went to first, thinking that we were ready to get solid support here with a tool that takes, instead of going to a single point and saying, well, what's my upstream and downstream look like? This is now going to a use. It's going to a use of again, I'll call it a factory floor with two models at the end and some information process tools and databases upstream. And what we're doing is we're taking risk attributes and we're using them in an algorithm to determine what the overall risk is of the topology, of this topology set. So again, I mean, Sean Keenan worked on this. It's basically a Gen 0 kind of thing, just an idea that if we take the complexity of the topology set, of the tree, and we look at it in comparison with the risk of the tools individually, we can come up with an algorithm for measuring the systemic risk of the tree. So we came up with that. But the beautiful thing here is not only could you do this in a current state, but when Gene built the data model, he added a level of states within the data model. So this is current state, but you could have a state that is a simulated state. You copy this topology, put it into the simulated state, and say, okay, now suppose we move things around. Suppose we consolidate databases, reduce one of those information process tools. Then you can see how it changes your risk metric, your tree risk. Furthermore, you can have obviously more than one attribute in your equations, and you can have more than one equation. In this case, we kept it kind of simple. Again, it's proof of concept, but you could get very fancy and say, well, if a tool is so many hops back, I want to completely ignore the risk because it's going to be mitigated away, some such thing. Attributes are attributes, again, because you're dealing with not only attributes of risk, and you're dealing with things like who owns it, who the data steward is, how old is it. It's up to your imagination as to what your queries are going to be. But as I talked to one fairly senior level exec, he said, the IOE is fantastic. He said it can do a lot of things for this company. He said, your problem is not what it can do. Your problem is to focus on something it can do that saves us money. And that's where knowing how the company operates is required. So here, this is another tree. This one happens to be 58 models, but actually has a lower complexity score and a lower overall model risk score. But I think the point on this part of the demonstration is, another pushback we get is, well, you're trying to boil the ocean. You're looking at the entire infrastructure of the company. Well, yeah, we are. That's where the real benefit lies. But it doesn't have to be done all at once. We're not talking about putting the entire infrastructure into the company all at once. We're talking about piece by piece. Put a piece in, see if it works, get your benefits, put another piece in, and all the while you're learning. So to summarize, I want to say that first of all, diagramming this is the heart and soul of the IOE. You've got diagramming and the standards that go with it. The attributes, tying the attributes and tying business metrics to the topology. The collaboration, it's a community tool, propagation of risk, but also propagation of contribution. And using attributes to go into different dimensions. And then finally, using your attributes for optimization. And with optimization, this becomes an entry into artificial intelligence. Are there any questions? Deborah, you want to come on up? So we took it's off Visio. We had a combination. So you have the diagram part and you have the attribute part. The attribute was simply an extract from the authoritative inventories, and that extract was loaded into Neo. I'm a business guy. I'm not a technical guy, so I can't go to the level of how it was done. But I know on the diagram side, it was a matter of taking the diagrammatic topologies and building a CSV file, doing a load script. But again, I mean, like Neo4j with Kettle this is probably the next way to go with this, because Kettle would be the obvious solution to that problem. Does that help? Okay. Yes, sir, in the back.
What level was this done? What's the level we're talking about in terms of processing?
Well, officially, and I don't know if this is an ISO standard, but this is level 3 or possibly level 4. Are you familiar with? Ah, good question. I like that question. Okay, so we started off at the analytical infrastructure level. Tools, databases, it's the physical infrastructure. But what the business really wanted was, hey, we've got workflow, we got processes, workflows, work steps, what we call task sequences. So we built the IOE, and hats off to Gene for making it work in the data model, where we integrate workflow steps with infrastructure. Now, the beautiful thing is, you have on your workflow step side, you have controls, maybe they're SOX controls. That's all on your workflow side, not on your infrastructure side. On the infrastructure side, you have other concerns. You have your server farm concerns. You have your health and hygiene of your databases and applications. In the IOE, you can merge those two and present to the business, hey, here's a combination of your workflow controls and your infrastructure risk.
So carrying that on, the red risk there might be a manual process, but the underlying tool or the underlying systems may have a red risk. Is that fair to say?
Well, yeah. So
at a layer, at a lower layer?
yes. And what we do in the IOE is we take each workflow step and pair it with what infrastructure makes that workflow step happen. And if there is none, and it could be like, you know, Joe makes a phone call to Jill, that's just a manual step. But for a lot of this, we marry those two side by side. So now you can see if you're on the workflow step side, and you know it's something we didn't add to the demo because there wasn't time, but we have, see, process flow. I could go into the process flow and say, well, what supports this process? What supports this work step? And then you can drill all the way down to your server if you want to go, yeah. If I understand, so if I understand the question, you're wanting, like, how can we present different levels? So let me answer that question two ways. One is, it's easily done because of Neo4j's flexibility and the way Gene built the data model, so that it's easily done. What we've done so far, to answer your question more directly, when the business came to us and said, oh, gee, you know, it's great you guys did infrastructure, but we're really a workflow step shop. We let the infrastructure, you know, handled by somebody else. Yeah, so we can show those two separately or integrated. Tom Sawyer was gracious enough to offer us custom attributes, and we'll probably at some point go that way, but to answer your question, we used standard geometric shapes, which Visio uses as well. Yeah, and the danger was, we actually looked at, I mean, Chris Tanner offered us lots, I mean, a whole world of different symbols, but we didn't want to confuse the user with, you know, hey, this is a gimmicky, fun thing. We wanted to stick to the basics. But who knows? Who knows in the future what we might do.
I wanted to let everybody know that we have a little table on the side here. If you want to continue, have more questions, come by. Otherwise, if you can hit the last slide. I think our time is up. Thank you all very much for joining us today, and see you at happy hour.
Great. Thank you.